So today we have with us Dr. Arnab Sur. He has more than 23 years of experience in the field of tunneling, underground structures, bridges, and hydropower. He has 15 plus years of experience in metro structure design, preliminary involving underground construction. He is presently working at Ayesa India Limited as general manager and also serves as head of department for structural and geotechnical team. So welcome, Dr. Sur. We thank you for accepting to speak on our webinar platform, and over to you.
Thank you. Thank you. Good evening, everybody. So, the topic for today is collar beam at the interface of tunnels, geotechnical and structural consideration. So, the outline of the presentation is a brief introduction, then geotechnical analysis of the problem, uh, the increased stress, ground stress at cross passage location, and special segment and increased lining support at cross passage opening, and sequence of construction, cross passage for TBM tunnel, cross passage for NATM tunnel, and structural analysis for temporary steel frame support at opening, and collar beam design for TBM tunnel, collar beam design for NATM tunnel, and conclusions. So, the tunnel is a cell element and it is a arch. So, this is a very strong structure until unless there is an opening is created. So when we create any opening, then at that opening location, the axial thrust of the tunnel that gets distributed. So that gets distributed, and at the opening location, there is a high concentration of stresses. And for that, to take care of that, we need some collar beam arrangement. So that collar beam arrangement will transfer the force safely by the cutout, means it will create a permanent solution for the cutout. And this collar beam can be in a TBM tunnel cross passage or in NATM tunnel to NATM tunnel connection. So here you can see there is a connection of collar beam for a main tunnel, NATM tunnel, and a edit connection. So going into the problem, uh, if we analyze a tunnel, then generally we consider it's an arch element, and all the loads are acting, lateral stresses due to the earth pressure, vertical forces due to the soil weight and ground weight. So until unless it is a complete tunnel ring, there is no issue. It is a mechanism. All the springs, they provide reaction, and it is a arch section. But whenever we cut that, then it no longer remains a mechanism. It tries to fall. So whenever we cut, we need to provide some alternate force path so that this does not collapse. So when we are talking when we are connecting uh, two tunnels, when one tunnel and another tunnel are joining in a perpendicular direction. But if there is any reduction in the tunnel section, suppose for here we have a enlarged tunnel and we have a smaller tunnel, and those are getting connected. At that location, this collar is a different behavior. In that case, this is basically called a head wall or a end wall. And here we don't design this for a to support the arch. This is designed only to take the earth pressure. So our problem is to the earlier what we have shown, that to take a interface between two tunnels when they are connecting in a perpendicular direction. So if we talk about the geotechnical part, whenever we have a ground, so in that ground there is the stress are evenly distributed. But whenever we make an opening in that ground, what happens? The vertical stress that want to transfer through the sides means some arch action starts to behave. And for that, there is a local concentration just nearby the tunnel section. And these additional stresses, whenever we are making a cross passage. So for a tunnel construction, for a main tunnel, already we have created an opening. And for that, a similar kind of stress redistribution happened. And whenever we are making another tunnel perpendicular to the main tunnel, what happens? This additional stress that starts accumulating on the main tunnel. So we need to take care of that additional stress. If we don't take the additional stress, then there can be overloading of that tunnel section. So this can be done in a 3D FEM analysis for sure. If we take any 3D software like Midas, GTX or Plaxis 3D, there we can model the entire ground and the interface of the two tunnels and their cross passages. And in that case, we can get the stresses at every stages when we before the cross passage construction, when only the tunnel is there, and after the cross passage construction, when there is some additional stresses are generated, and this is the long section along the this cross passage. Similar thing can be done in a 2D behavior also. If we generally in industry we generally don't prefer for a 3D analysis, we generally prefer for a 2D analysis. So if we do a 2D analysis, then also similar behavior happens. So what happens in that case? There is some additional stresses accumulates just nearby the opening we are creating. And if we see a stress distribution, if we see there is an analysis we have done for this, and we have taken the vertical stress sigma V plot, and we can see away from the tunnel, it is just gamma into H, which is coming 615 kilonewton per meter square. And nearby the tunnel, there is some additional, and that additional value is a quite big value. If we take the difference, it comes 848 kilonewton per meter square. Similarly, for a different section and for a different overburden, this is also shown. And for the crown section, this is coming, the additional stress is coming around 160 kilonewton per meter square. So if we see this is, suppose this is a cross passage, and this excavation, creating this excavation adds a additional stress, and that we can calculate from a 2D analysis. So here, if we see at the far area where there is no change in the stresses, there we have a 309 kPa, and at the crown of this opening, there is 720 kPa. So this 411 additional kPa that applies on the main tunnel, which is going perpendicular to this section. So we take that in the account. So we apply that stress in the main tunnel, and whatever comes the additional forces in the lining, we accommodate that stresses there. So generally in TBM tunnel, wherever there is a cross passage, which cross passage maybe we have approximately 3 meter width of the opening, means the total excavation. So we generally take 7 rings for additional with the additional reinforcement. What we do there, we do the similar thing. We do the additional stress which is induced by this cross passage on this tunnel lining. So not only the tunnel segments which are getting disturbed for this opening creation, apart from that, the nearby segments also need to be reinforced more to take the additional stress. And similarly, similar behavior happens in NATM tunnel also. This one section we have, this is from one of our project in Mumbai. This is for Grant Road Station, where one tunnel section, one train's platform comes inside the curtain cover box and another inside the NATM tunnel, and we create edits at several intervals to connect this station box with the platform. So there, for analysis, we have estimated what will be the additional stress on this tunnel, and we have applied that. And this lining we have designed for some additional force of this additional ground load, apart from all the other soil overburden and building surcharge. So our foreign attempt, since we have two lining, one is primary lining and one is the permanent lining. So both the lining has to be designed for this additional stress, because this additional stress, initially this is taken by the primary support or primary lining. But since the primary lining is not designed for a lifetime of the structure, maybe it get deteriorates within 5 to 10 years. So that additional load will eventually come on the on the secondary lining or the permanent lining. So both the linings have to be designed for this additional ground stress. So if we see the sequence of construction of how a edit or a cross passage is created. So for a TBM cross passage, these are the sequence we have listed. So first, what we do from one of the tunnel, either upline or downline, we start creating drainage holes, and then we do some forepoling at the roof portion to support the roof section, and then we install a steel frame, either a complete steel frame or a partial D frame, to support this area where we need to cut. Then we cut the segment at that location, and when we cut the segment, then this axial thrust, rather than going through this lining, this starts going through the D frame. And then we open the ground and we start installing the primary lining. And by a heading and benching excavation, we progress. And eventually we prepare the entire primary support, and then we start applying the permanent lining. We cast the permanent lining. So this is the sequence. So this is for a soil we have shown. And for rock, if the rock quality is good, then support is also reduced. So this is one for one station in Mumbai, where we have a rock of class 3 or better quality basalt, and the rock was self-supporting. So we needed a very minimum support there. This for Kalva Devi station. And there we followed this sequence. We just installed few rock bolts to hold the segments. And then we opened the tunnel section and we started excavating from one tunnel, downline tunnel, to the upline tunnel. So thus the this cross passage is created there. So I have is a pictorial presentation for NATM, this cross passage construction for a TBM tunnel, where step by step all the steps are captured. So the first step is from the inside of the TBM tunnel, we install a frame, steel frame, which we called a D frame because it looks like a D. And this ensures that whenever we make a, we try to cut the lining inside this frame, the all the forces from the these both the sides will get transferred through these frames. So after installation of this frame, we start cutting by core cutting. We cut the lining, and this the soil is now the soil can be visible, and this soil says based on the quality of the soil, we prefer either this water to be drained, or we sometimes go for a grouting on this area. So this is for Kanpur project, Kanpur 05 project. So there we applied some grouting at this area. And as soon as we open this we get the access, we start installing the heading for this opening. So you can see the next, we have made some progress in the heading. And here we have made further progress in the heading with the same repetitive. We apply the shotcrete and spiles. And this shows the complete primary support. So these are all shotcreted with a wire mesh. And you can see there are instruments. We have got optical targets there to see the deformation, and daily measurements are taken. So this is the completed primary support. So after primary support is complete, then we install waterproofing membrane, because waterproofing membrane is vital to protect the structure and to take all the water outside to avoid any seepage. So this waterproofing membrane is installed, and then the reinforcement laying for the permanent lining started. So this is the closer view of the door. There is a steel frame. There are actually two steel frames. One is installed from the inside of the tunnel to create a opening in this door, for this door. And we get another steel frame which are installed outside of the TBM tunnel, which will be a permanent support to this opening. This we call a collar beam management. So this, here we have a steel collar beam. So this is the beam, and these two are columns. And you can see these holes. These holes, since it is a this is a cross passage with some. So there are many utilities which come inside this cross passage. So these holes are made in the this lining, TBM lining, so that the utilities can come inside the cross passage. And this is a view from inside of the tunnel, where we can see the cross passage is under construction, and this core cut lining, and a small view of this steel frame which is installed from the inside of the cross passage, that is visible. So this is the when the invert is already uh, cast and the overt reinforcements are already tied, and this is not, the next step is casting the entire final lining. So when the final lining is cast, then it looks nice and it is clean, quite clean, because the permanent structure is done. So going to the structural analysis, we have a steel frame which is temporary, which is installed from the inside of the tunnel to start the beginning of cutting of this lining. Then we have a steel frame at this door location, which will take this loads axial thrust in a permanent situation. And when we complete the entire cross passage, we remove this temporary steel frame. So at that time, everything is supported by this permanent steel frame only, and which we call a collar beam. So in this view from inside of the tunnel, you can see both the temporary D frame is visible, and here the opening for the door is there, and the permanent collar beam and the column arrangement, steel column arrangement is there. So for the temporary D frame analysis, this can be done in any structural software where we can model the structure as per the actual geometry and actual stiffness of the members. And then we apply the load, which is the axial thrust of the lining. And this acts in the same direction of the lining, since this is supporting perpendicularly the lining. And then from the analysis, we can obtain the axial force and bending moments. So based on that forces, we can verify the sections, whether they are safe or not. And coming to the this drawing part, this is the drawing part where we have shown the permanent collar beam. So in the permanent collar beam, uh, this is only the purpose is permanently supporting this opening. So the door opening is generally 1.4 meter width. Fire door, we install a fire door here, and that door is 1.2 meter wide. So we need to create a 1.4 meter opening so that the door frame is also accommodated. So this steel frame, this is a permanent solution for this opening. So uh, this takes the axial thrust, and this with a steel bracket it transfers to the collar beam, and then it transfers to the this side steel columns to the other side. And here also we have a thrust, so these two thrusts are balanced, and this is the alternate path for the thrust. So we have a thrust at the top of the collar beam and bottom, and both are basically we create a alternate path for this axial force, and this opening remains forever. So for coming to a design part, this is very simple design, because as we explained that this force is the lining thrust is the force which is acting on this beam. So considering a simply supported beam, this can be designed, and the columns can be designed for that axial thrust. And this steel frame is then completely embedded in concrete to provide a durability of this steel structure, and this remains there for its lifelong of the structure. So this is the final situation where the collar beam is embedded inside the concrete. So coming to the collar beam for NATM tunnel. So for NATM tunnel, it is a bit different, because in NATM tunnel we have two lining system. One is temporary lining and one is permanent lining. So for temporary lining, what we explained at beginning of the this presentation, that since the this access edit construction creates some additional ground forces on the tunnel. So we already designed the primary support of this area, which portion is affected by this construction of this edit, that we already designed for a higher forces. So that lining is already capable of taking that. But for a permanent lining, because since that temporary lining will not last for a long, so we create a permanent lining also. So this permanent lining, there are some additional forces. So there is force due to water pressure, and also from the this ground loads. So what we take here, since this horseshoe shape section or a circular shape NATM section, these get discontinue at that access tunnel location. So we need to provide alternate path for this thrust. And generally this is created in a RCC. So a massive RCC beam is provided here. So for analysis, we can do either by a 2D frame analysis. So we can create the geometry of the collar in any software, and we can apply the load of the thrust on that collar beam from both the top and bottom side, and we can calculate what is the forces coming on that collar beam. So we can get the bending moment, axial force, shear force, all from the 2D frame analysis. And based on that, we can provide a design for that, which will take the this thickened portion for the additional forces, and this will bypass these stresses which are discontinued because of this opening creation. And there can be a fine-tuned analysis also. We can make a 3D of this junction. Here we made a 3D of this junction where both the tunnel dia are same. We had a 9.5 meter main tunnel, and the access edit also, that is also 9.5 meter dia. So here we can see the collar, and this is done in STAT, and we made a grillage model of this. And the loading of the loading applied on this model is the vertical stress from the ground, lateral stress from the ground, and the water pressure. Water pressure is additionally act on the this lining, because it's a permanent lining, and also seismic forces are applied. So in this, since a 3D model is done, we can along the this edit section, we can get the bending moment or shear force, and along the cross section of the any cross section, we can get the bending moment and shear force, and we can design accordingly. So this is a section where we have shown the reinforcement detailing for this, and the collars are pretty heavily loaded, and their reinforcements are generally 32 dia or 40 dia reinforcements are there with a high shear links. So for all the things what we have gone through till now, what we can conclude that at locations of cross passage or edit connection, which are getting connected to the main tunnel in a perpendicular direction, there is a ground stress redistribution at this junction, because main tunnel is constructed, then again another tunnel is constructed, and the design of main tunnel should accommodate the additional stress of ground at this location. The second point is that the geotechnical analysis for the above point can be done in a 3D FE software or in a 2D FE software, whichever suits us. And the collar beam shall be designed for axial thrust of lining, and this collar beam should bridge the opening created in the lining. And the collar beam design can be done in a simplified 2D FE frame analysis, or can be a 3D structural model can be created. So that is all about our today evening presentation. So thank you everybody for listening. So I would like to listen if any one of you have any questions on this.
Thank you, Dr. Arnab Sur. So now our floor is open for the questions. So anyone has a question, kindly raise your hand or you can post it in the chat box. Okay, so the people are taking time. I have some questions.
Yes.
So you have actually mentioned that in most of the presentation you have shown the D frame. So what are your inputs about using D frame and a ring frame? What is the efficiency? What are the design consideration difference in design considerations? With what the like it's a structural part you can do anything, but what is the design efficiency? So I want to know about that.
Okay. Actually, there are many options. As we all know, there can be many options for a same problem. So there are alternate option of a complete ring support for this tunnel. and this D frame is just a portion which is installed at the periphery of this cutout. So benefit of this D frame is that this tunnel, you can see this is not affected. So if there is any, there is no restriction to this tunnel, and this can have any marking operation or any other, if the tunnel is under construction, main TBM marking is going on, TBM installation is going on. At the same time, we can have a D frame and we can start the construction for a cross passage. And that is the benefit of a D frame. So I think that's the benefit.
Okay. And we in the presentation, I've seen the reinforced lining as the final lining options alternative. So, what is your take on the steel fiber reinforced concrete as a final lining?
Steel fiber reinforced lining is a, means that is a, I would say that is a part of lining designing. Means for a collar design, it will be having a similar scenario, because whether we go by a reinforced concrete segment or a fiber reinforced segment, in both the cases, the tunnel lining is having a primarily axial thrust and some bending moments, and that is to be taken care at the collar location. But yes, we can go for a fiber reinforced concrete, but fiber reinforced concrete, the problem is that there are limitations, and maybe with a very good soil condition or a rock condition where the stresses in the tunnel lining, the forces in the tunnel lining is primarily axial and bending is very less. In that case, fiber reinforced concrete can be used successfully.
Okay.
For a soft
So,
ground condition, it is difficult.
okay, thank you. I have more questions, but let us address to our
I think,
attendees.
Rushi, there is two question. First one from
Yeah.
Michael, that what percentage of the increment or in axial force and moment to be considered in the design of tunnel segment and CP, as the local stresses are too high than the other area. So this is the first question.
So the replying to the question, so for that we need to do a analysis. Maybe we can make some gross increase in the forces, but that can be either overestimated or maybe underestimated also, because this force, whatever force will be additional stress that comes into this area, that depends on many factors. That depends on the soil properties, depth of the tunnel, size of
Yeah.
the passage we are creating. So we can have an analysis of this cross passage, an independent analysis, and we can see how much stress is increasing locally at that area.
Yeah.
And that stress we can apply in the main tunnel to see whatever there is an increase. So generally there is some increase in this area, and for a soil condition, definitely we need to increase reinforcement at this zone.
Yeah, means, sir, it will be case to case basis. There should not be any generalized that 10%, 20% like not things, because it's totally depend on the ground condition, the area, and on so many other things also. So
Yes,
it can.
right.
We have another one question. I think
We have
Javed Sheikh. Yeah,
yeah. So
yeah, yeah.
Javed, can you just switch on your mic and camera? It's fine for us.
So, Mr. Javed, are you?
Yes, sir.
Yeah.
Yeah, you're audible. You can just give out your question.
Sir, my question is that while constructing the permanent lining, we have encountered the water seepage, and we constructed in that water flow. The lining will be how much years it will decrease its lifespan?
Okay. For water seepage, when you
If
have a
we
water seepage, then you have options of either grouting that area, or you can have a option of dewatering that area. So that water is to be controlled at the for sure. Means we cannot, we should not concrete when water inflow is there. We should definitely make some arrangement to arrest that water seepage. And if that is there is a very less seepage coming inside, then there are procedures of channelizing that water. You can put some channels, temporary drain channels there, and you can cast the lining.
Sir, my question, my another question is that if the reinforcement is under rust and corrosion, then how will be the effect on that particular lining, sir? If the
So
reinforcement which we have constructed, is there if by any chance is there any less cover to that reinforcement, and the reinforcement is exposed to water, then the reinforcement is undergone the rust or corrosion, then how will be the lifespan of the structures, or how can we ensure that how many years it will be stable or serviceability?
look, first of all, our durability consideration that specify a minimum clear cover, grade of concrete, and if the construction is not as per the standard and we are not able to achieve the conditions, means if we are using reinforcement which are not corrosion free, and if we are using cover blocks which are not ensuring proper cover to the reinforcement, then definitely there are impact on the durability and life of the structure. And that can be done on a case to case basis, means how much cover is actually provided, what is the contamination of the water, maybe the water is clean, maybe the water chloride content is very high, maybe there is some acidic thing is there because of some sewer line nearby. So that detailed analysis is to be done. But there are codes, there are ways to find out. So that can be done always. But the corroded reinforcement, if we are using at the first place, that should be avoided. That is no way we should allow any corrosion.
Okay, sir. Thank you, sir.
Uh, I have one question that whether seismic design, how we will design the it for the seismic forces, since it is connecting to main tunnel. So we can ignore the seismic forces, or we have to consider some seismic forces for, especially for the higher seismic zone area like zone 4 and above.
For the collar we are talking. So in the
Yes,
collar,
yes.
yes, we can consider the seismic, because this collar beam or this steel frame, they are basically is there to bypass the opening we are creating. And the input for that is only the lining forces. So this analysis, what we are doing, in that we can take a combination of these forces, means not for this, for this thrust we can take a thrust including the seismic effect, because because of the seismic there is some increase in the thrust, there is a plus minus effect. So that thrust we can take care in that design. We can increase this axial force because of seismic effect.
And what about the ground settlement monitoring during this excavation period? Is there any additional precautions need to be done, or for such excavation?
Yes, for sure. For a cross passage construction, generally we try to avoid just below any important structure. Maybe we can do a little bit change in the alignment, and we can shift the cross passage some 15-20 meter along the length of the this alignment to avoid any important structure. And yes, there is a settlement monitoring inside the tunnel also, and outside the tunnel at the ground level also, and the buildings also. The monitoring is a part of that, and we define a limit, alert action, alarm alert action. All three limits are defined.
So I have yet another question. I think okay, one more question is there. So Rahul Sharma is asking, can you please elaborate little about shear forces handling at invert level of the junction of the main tunnel and edit?
Can you repeat once?
Shear forces handling at invert level of junction of main tunnel and edit. It's like the junction between the main tunnel and cross passage or edit or anything.
Okay, okay. So look, this is whenever we are using a, this depends on what structural system we are following at this collar beam area. So if we are using a steel frame, in that case we are providing a complete support to this lining. So what we do here, we cut the this lining, and we install this steel frame, and then we grout whatever gap is there in between this steel frame and this collar sorry, in this lining. So there is no gap between these two, and whatever axial is coming through this, it will means axial. Whenever we consider axial, there is a axial at this lining at this elevation, and at the invert elevation, at the invert location also. So both these two axial are almost similar, so they balance each other. Okay, so this is for a steel beam system. Now if we don't provide the steel beam, and if we want to go for this RCC collar at this area, okay, so in that case we need to provide some connection. Here we are directly resting on the steel frame, and if we are not resting on the steel frame, we are connecting from the side, then we need some shear connection between this precast lining and the cast in situ, the collar. And for if we go for a this thing for a NATM situation, in NATM we are casting monolithically. So the shear we are considering here for the whatever shear is coming, that is transferred to the collar beam, and we are checking already the interface shear here. So that will not be a problem for this NATM section. So is that clear, or?
I think is it clear? You mentioned. Thank you.
Yeah. So any other questions?
Sir, in tunnel linings, where we have to provide the CJ, sir, construction joints, is there any particular thing is that we have to provide in this area only? Means where the edits are farming, yeah, nearby cross passages are, means where we have to provide CJ. Is there any particular class for it?
Look, CJs, if we speak about CJ can be between invert lining and the overt part.
Yes, sir.
Okay, CJ can be along the length of the tunnel.
Yes, sir.
Okay, and at the cross passage area, since cross passage, these collar beams are cast later, so we provide some CJ here also. Okay. So that is based on CJs are based on construction requirement mostly. Generally, we civil engineers, we want to avoid the construction joints and we want minimum number of construction joints because construction joints, they create problem, they create water seepage, but there is no reduction in strength because of construction joint because all the construction joints are treated for 100% strength. We do the complete reinforcement continuity there and we lap everything there. Okay, we prefer a staggered lapping there. So there is no reduction in strength at the CJ location. So that CJ can be planned based on construction, but again, minimum number of CJ should be there.
Okay. Sir, if over excavation is happened at the site, then this reinforcement can be how we can ensure that then the cover will be more, sir, at the outer face.
Yes. Over
Then how?
excavation is not a problem. If there is over excavation, then this lining thickness will increase at that location and that will be a kind of backfill concrete.
But sir, the area of reinforcement will be low, na, sir. When compared with the area of concrete, the area of steel which you have designed, then it will be the area of reinforcement will be less. The area of concrete is higher, sir, higher than the area of reinforcement of steel. Then how can
No,
we
that
can
will
ensure?
not be there because that area you don't require as a RCC section
Yes, sir.
because that is additional concrete you are doing.
Okay, sir.
So that is not a problem because you are not utilizing that section as a part of the RCC section.
Yes, sir. Yes, sir. Okay, sir.
Or if you have such concern, you can rectify that also. You can do some backfill concrete before constructing the permanent lining. That also can be done.
Yes, sir. We can also done with the short kit also it will be filled.
Yes,
Over
yes, with
excavated
some additional shortcut that can be filled.
short kit. Yes, sir. Okay, sir. Thank you, sir.
Okay, any more questions? So I think this is it from our audience. So Chiranjeev sir, do you have any questions?
No, it's just it's time to say thanks to the speaker. You can conclude with thanks note.
Yeah, okay. Thank you, Dr. Arnab Sur, for a wonderful webinar on collar design. It was a unique type of webinar having geotechnique as well as structural part. So, and yeah, it was a very informative webinar, and I think our young members and all the members who have attended have gained much information and knowledge from this webinar. And to the people attending, I would like to mention that we have all our webinars, past webinars on YouTube. You can follow us on LinkedIn, webinar, and YouTube as well. LinkedIn, Instagram, Facebook, we are quite active in social media. And thank you once again. And I would also like to invite all of you to join our TAIym for the young members below 35. I would invite you to join our group. So you can mail us at tiymyoung@gmail.com your queries and anything. We'll share with you all the forms and everything. And once again, thank you, Dr. Arnab Sur, for your wonderful webinar.
Thank you, Rushi, and thank you, Chiranjeev, for arranging this. Thank you so much.